now I'm going to hand over to Ikram, who is going to talk about the web app security. Um,
Yes, this is Ikram. Can you see my screen?
yes.
Yes, so I'm going to talk about web app security. So as we all know that the time is fast approaching where you only need web browser to run apps. So web browser needs just HTTP requests, which are lightweight, and it includes JavaScript and other frameworks which are used. So if you want to keep in mind security, then you need to do a proactive approach and use best practices out there for development and try using clean code principles. So if there's any simple error there on your code, then it can cost you millions of dollars of losses. And if your web app is hacked, then it means your whole system is compromised. And if there are any security breaches in your app, it means it harms your company's reputation. And there are many apps there on internet. If they are not uh, implementing the security features correctly, then they can be hacked, even if they are using SSL. Like here, there's example. You have apps like billing, human resource, legacy apps, or databases. Even if you're using firewall or SSL, attacker will go into your website. They can put something in your input box or some other fields. So SSL doesn't, stop attacks that directly target the server or app on client side. So SSL does, uh, if the application uses SSL, this simply means that the other user on the network cannot view or modify the attacker's data in transit. So attacker can control the other side, other end of the tunnel. So attackers can send information to server through tunnel. So because of attacks, many vulnerabilities are there, which are faced by web apps, and there are some advanced ones as well. So I'll go through briefly some of the basics ones which are common. So first one is broken authentication, authorization, and session. So here the client is making request to server and this connection is established. So what the attacker is doing, they are doing packet sniffing and they try to hijack the session. Sometimes they hijack the cookie and they sniff over the insecure connection. So there's a session ID theft. And let's say if you're trying to log into a website, you will get back a session ID. So if your session is hijacked somehow, then attacker can use the same session ID to log in to the website. So there's sometimes exploit password reset. They can try brute force the login, and if your password is not secure, then they can discover the credentials as well. Sometimes it happen with public profile people, and it happens when this bad cryptography is used or weak algorithm is used. So common defenses are to minimize the sensitive data storage, protect cookies, encrypt your cookies, and expire sessions quickly and challenge users on key actions, and allow and encourage strong passwords and implement login rate limiting and lockouts. So common one example was Citigroup hack. There was easy to detect web flaw on web app. So brute force attack exposes 200K accounts. So next one is unvalidated redirect and forward and missing function level access control. So here you're going to a website to a link, which is the desired destination. So instead of this, you're going to the malicious redirection because of attacker is giving you this information. So you're going to click here to this website. So instead of this, attacker can give you this website where a malicious code can run. And the missing function level access control is you are logging into a website, you'll get an admin view back, and attacker will go to go directly to that admin view and return the page because this function level access controls are missing. So, so it's because the UI is showing navigation to unauthorized pages, and it's showing admin sections without proper access level control. So there could be some authorization check missing. So common defense is to use clear authorization model, use roles and membership, proper QA around users and access roles, and always test unprivileged roles and check your post put calls and async calls and whitelist your URLs and use trusted allowed URLs for redirect. And if you are using, it's the best to use ID, like, and then resolve the ID through reference map when you are redirecting to another URL, and check the referer in the header when you are passing to another website or URL. So an example was Mian support help desk, where the vulnerability in apps allowed complete takeover of the system. And if and other the government trusted websites are also vulnerable, like someone can tweet like this is the government website and click on this link, and if this link contains something strange, then user think it's a government website, but behind that is phishing or malicious site. So another vulnerability is security misconfiguration and sensitive data exposure. So here the attacker gaining access to insecure resources of website due to misconfiguration. So attacker get exposure of a gateway risk, and user log onto the website or HTTP and doesn't know about encryption, and attacker got onto the network and does sniffing. It's kind of like a man in the middle attack. So they could retrieve user password. Attacker can manipulate data or HTTP. So it happens because there's insufficient use of SSL, login not loaded over HTTP, cookies are not secure, and bad cryptography is used, weak algorithm is used. So common defenses are to turn off features which aren't needed in the configuration. Do you really need directory browsing on the web server? And apply the principle of least privileges and fine tune your app security config and ensure that it's production ready and not always use default settings. Fine tune that. If you're using package management packages, make sure they are up to date and package management practices are employed, and minimize the sensitive data collection here. So if someone can send phishing email, it should be properly checked, and it should be done according to the security principles. And if you're using HTTPS, make sure it's wrapped around to the whole page. If you are using iframe in the page where you have a simple HTTP page, so make sure everything is wrapped around HTTPS. And if you're using cryptography, make sure you're using strong techniques. And if you're using keys, then you can use like Azure Key Vault or similar cloud tools. Security misconfiguration example was Tunisian government account theft, in which the hacker hacked Gmail, Yahoo, Facebook logins, and social media site Wiki.com, where millions of password leaked recently. And if you put this on Google and hit search, you will be able to get lots of information where, because of the security misconfiguration, you will be able to see like lots of logs and stuff where you can publicly see. So that means there's a problem there, that they are showing it publicly. So they have to do the configuration correctly. That shouldn't be public. So if our attacker got hold of this data, sometimes there could be API keys inside or database passwords. So another common vulnerability is SQL injection. So in this one, the understanding of that is that user is trying SQL injection by using SQL query. So attacker input SQL statement in web form, and website gets the request that is converted into query and run against database. So if you are trying to access a widget on a website, like A1 widget, so this means in the database that select all from widget where ID is A1. So if a user is providing, attacker is providing this text instead of A1, so query would look like this, that or 1 equal 1 that is provided here. And then the two dashes means that everything after this is commented out. So 1 equal 1 is always true, which will run. So it will no longer return one record, but it will return all records. So imagine if you are accessing a user, single user, it will reply you back all the users with all the passwords and emails and everything. So another injection is union operator, where if you are running one query, you can try union operation. It will and put in another query, it will give you more records. So common defense is to whitelist untrusted data, reject malformed input, strip malicious characters, use parameterize SQL statement, use SPs, fine-tune DB permissions. So one example was Sony hack in 2011. So single injection access everything, and Sony hit badly by a few kids. So another one is cross-site request forgery, CSRF. So understanding of that is that user is trying to log into a website, and then user get backs a token or session ID back. And then attackers send the forged request disguised as a legitimate communication from bank or website. And then user unknowingly forward that request to the website or bank. And that request is executed by bank or website using the previously assigned token that was sent to the user. So attacker knows the HTTP post path and is tricking the user to make the request with the request body. And he knows what the request body is. And then in the request body, you can change the account number or amount, and the auth cookie is automatically sent with the request. So it happens when the web app is not secure enough. So common defenses, I use anti-forgery tokens, like there's a module in .NET that we are currently using. So token add randomness to the request, so which is unique to token and unique to request. So if they don't match together, request is rejected. And always validate the referrer in the header, and you can use custom headers while making the request to employ fraud detection patterns. So last one is cross-site scripting exercise. So in cross-site scripting, it accounts to roughly 80% of all security vulnerabilities documented by Semantic. It occurs when app takes untrusted data and send it to endpoint without proper validation and escaping. So XSS allows attacker to execute script in the victim's browser. So attacker is injecting a bad script here and getting back the valuable data. Like if I'm going to a website and searching for ipip, attacker can input like this script, and if it is not properly handled, it will give you back all the cookies. And it can give you back like auth cookies or tokens. That's what attackers need, and this can simply hijack your session, and they can do more stuff, and they can try like XSS injection directly into database. So common defenses are whitelist untrusted data, and check what input you trust. Does it adhere to expected pattern? And some input checking in the backend as well. And you can use tools like Nisos and Nikto to scan apps. One of the example was Sam Kankar's MySpace hack, where the worm spread to friend and that to another one and spread to millions account. And that was like div and with a minified JS code inside. And there's one website there, accesseat.com/archive. If you go there, it will show you list of websites which are vulnerable to XSS. The tick mark says that they have fixed the problem, and this red cross shows that they are still having problems. So there's a big list there with website having this problem. Okay, so the last slide is this one, secure your practices. So imagine if you are using uh, software development lifecycle, or you're using agile or scaled agile or DevOps. So make sure security is injected there in your practices, in your technologies, resources, access areas, and you're using roles and responsibilities. And if you're coding, then you should have code smell and linting process there, and make sure you're doing the automatic and manual peer reviews of code during multiple points during deployment process. So quality should be across the board, like it's everybody's responsibilities, keeping in mind the security aspect. And development pipeline should be introduced and properly configured for environment like dev, integration, staging, and production. And DevOps should be secure as well. Like there should be auditing logs, penetration testing, which will be covered as well in a few minutes. And everything should be secure. So any vulnerability in the DevOps should be scanned, log report should be generated. If you are doing microservices, then make sure you're using security token service, where you can use a UI where you can generate token and assign it to different apps you are using in your organization. And you can set the token validity and lots of other things you can do if you use this token service. So in the end, I would say the continuous monitoring and scanning is vital. Over to you, Zishan bhai.
Thank you very much, Ikram bhai. It was very, very informative. And as usual, we are receiving a lot of questions. IT professionals, if you're an Irish Pakistani IT professional and wish to support this idea, please get in touch with us. Do join us, share your ideas, help us to refine these ideas, join us to practically deliver those aims and objectives. And finally, IPIP, an open access platform for Irish Pakistani. It's envisaged by ICT professionals, organized by ICT professionals, and supported and managed by ICT professionals. With this, thank you very much for attending this, and I would like to give a big thanks to all of our panelists for taking out their valuable time to present this topic. With this, thank you very much, and Allah Hafiz.
Allah.
Thank you.
Thanks. Bye.
Thank you. Thank
Thank
you,
you.
guys. Have a good weekend. Thanks.